Because Jason is someone I've known for a number of years, and it's been really fun to work with him back and forth. But he originally would help out with ng-conf, and I learned very quickly that this is someone who's exceptionally talented and kind of quietly so. He doesn't go around and boast about it. He's not a bragger. He's not someone that showboats. He's just Jason. And uh, quickly he came on, started helping out with the Angular community meetup, became a co-organizer, and has since started his own streaming channel. I'll have to put the link in here in a minute, but it's Shokomil. Am I saying that right?
Perfect.
Awesome. Okay. And he builds great things. You learn a lot of really, I think it was the first time I'd heard about Drupals and really kind of dug into that. But uh, you just learn some of the most awesome stuff that you're not going to just come across, in everyday programming, but you kind of put it in the back of your mind. And then when you're off coding yourself, you're like, oh my gosh, I remember learning this. So, really great channel to follow. And because of his work there, he's become an Angular GDE. So, just exceptionally talented. Like I said, we're very lucky to have him. And what I love about today's workshop presentation, whatever, is that it's not just about the tests, it's about that forethought, the leading up to the tests and how really to write your code in a way that sets you up for successful tests. So it's kind of like a full picture thing, right? When you're testing, it really isn't just about that end action. You need to be thinking about it while you're writing the code. And so that's what we're gonna do today. And I think it's great. I'm so excited. So yeah, there you go. And
Awesome.
yeah, I'll just
Thank
forget.
you, Brooke. That was extremely high praise. I appreciate
All
that,
right.
especially coming from you.
Well,
Um,
it's well
so
deserved.
thank you very much. Very much appreciate it. I recently, so I just submitted to the CFP for ng-conf, and I added code philosopher to
Nice.
my title there. Um, and there's a reason for that. And I've discovered that your philosophy about code changes a lot of what you do at how you write your code, um, how your code behaves, and the quality and maintainability of code. So we're gonna start with a little bit of philosophy to go from the beginning. And I have this metaphor that I've been thinking about when we talk about code and testability and maintainability. Like all of this stuff goes hand in hand. When you write testable code, you write maintainable code. When you write testable code, you write composable code. All these good things that we learn about in computer science, they become possible because of the philosophy that you take with your code. And so I want to start talking about the idea of a flashlight, or if you live in, outside of the US, a torch, right? A flashlight has one purpose, and it does that purpose well, but there are parts to the flashlight that are really important. And if we talk about like the most basic flashlight, and I'm drawing these with a trackball, so we'll see how my drawing skills are, right? Luckily, streaming has taught me, well, that got out of hand, but luckily, streaming has taught me how to use the amazing Excalibur tool. Um, but with a flashlight, we've got some pieces. And the pieces that are important in our flashlight um, are the batteries that we've drawn here. And then typically there's this switch, right? And my drawing, um, and this switch, its whole job is to take the power from the batteries, connect this line, and then this line connects to the bulb. in our flashlight, right? Um, and this allows our flashlight to emit light, right? Why am I talking about a flashlight? Well, there's a very interesting thing about the flashlight. The flashlight is composed of parts that don't care about each other, right? The batteries weren't made for the flashlight. The light bulb could have potentially been made for the flashlight, but it can function in other places. The nice thing about these parts is they're easily testable, right? We can grab a battery tester and we can figure out, hey, are my batteries bad, right? Um, we can figure out, hey, is it the bulb that's the problem? Why I'm not getting light? Is it the switch, right? We can move the parts from one flashlight to another and figure out, is it the switch that's broken, right? We can easily test all the parts in a simple flashlight and figure out what's going on, and the flashlight does its job. Um, the nice thing about a flashlight is that you can pick one up for like five to wow, that was horrible. Let's do that. And right, five to like, I don't know, $20 will buy you a fairly simple flashlight, right? What's the opposite, right? Like, what's the most enterprise flashlight that we can come up with, right? Um, and the most enterprise flashlight that I can think of, everybody carries around in their pocket and they use it all the time. And it's got, maybe a fruit logo on the back or a little, who knows, right? This is the most enterprise flashlight that you can come up with, right? It's your phone. Um, and it's way over engineered as a flashlight, right? We can't replace the battery. We can't replace the light bulb, right? This is the most integrated piece of software. It's the worst flashlight when it comes to composability and things like that, right? Obviously, it does more than that, but testability on this is also difficult too. Oh, you'll replace the battery for me? I appreciate that, right? If your flashlight breaks, exactly like a Tesla car, right? We can come up with a lot of ways, a lot of different things that we could think of as being enterprise, right? And in the US right now, we're looking at like $700 for a phone. Um, and this becomes a good metaphor for kind of the way enterprise software can be built, right? We can take the idea that we're going to build a flashlight. Oh, we're gonna build these parts that will be testable and it will be composable, right? We can move these batteries to other parts. We can move the bulb to other parts. We could potentially build a new body and move parts into that new body, right? And our code in the long term becomes more testable. It becomes more maintainable, and it's cheaper in the long run for your company to build like a flashlight than it is to build your code like an iPhone, right? Where everything's integrated and packed together. So this is the philosophy lesson right off the bat. Let's talk about what we're building today, right? And what we're trying to test. So I've already got things up and running. We used Junie in um, from JetBrains. We use JetBrains Junie to generate this application. And I love modern AI because I asked Junie for 3 sentences to just generate um, a little bit, and it actually generated a pretty impressive application. So with 3 sentences, this is what Junie built for me. Um, right? We've got our Teenage Mutant Ninja Turtles. We've got the top characters by high score. And this is all the Junie code. I haven't changed anything, right? And if we click on the details here, we'll see that, hey, we get the details down below. If we click on like Michelangelo, it changes. We can close the details, right? Very, very simple. Junie is scary, amazing. I agree with you there, Caitlin. It is amazing, but that scary actually works in very different ways, right? But it was really, really cool watching Junie recognize that I'm using Angular. It created services, it created models, it created all of the starting point where we are. Um, So let's talk about the code that Junie generated because Junie is trained on enterprise code. And so Junie generated some very enterprise code for me. And this is code that I've seen in code bases all over the place. Um, and there's some issues that we have with this code. Um, and we're not going to dive into all of the issues, but there's some things I want to point out that make this code very difficult to test. Um, so as we come down through the code, we can see that there's logic in the code, right? Um, we can see down here that there's more logic in the code where we set the selected character to null. Well, what does this tell us? This tells us that the state of this component exists in the state, and we're mutating the state um, through actions in our template, right? This leads to code that's difficult to test. Or it can lead to code where we write ineffectual tests. If we unit test our components, logic in button clicks is often forgotten. Um, and that's a big deal, right? Because if that logic breaks, our unit tests aren't going to catch it. Um, I argue that unit tests are not the right way to be testing your components. And Raphael gave a great session last week where he talked about the Angular testing library. And Angular testing library's philosophy is that you test your code the way the user is going to use the code. Um, which means that you shouldn't be writing unit tests for your components, which is, an interesting thing to say. There's some other problems with this code. Um, all of our stuff is public. I added the service here. It was injected in a constructor. I moved it to this type of inject, various reasons for that, but the best reason is that this is the safest long term. For your constructor injectors to work, Angular actually has to turn on a flag in TypeScript. If that flag's not turned on, then your injectors in the constructor don't work. This is safe against that. There are other issues going on, and we'll see those issues with the tests, right? Like there are a lot of RxJS experts out there going, man, this Junie code is scary. This RxJS is scary. The RxJS is scary. Um, but there's a bigger problem here with testability, and we're going to take a look at that when we take a look at the tests, right? The service itself, I don't actually have an HTTP backend. It's just a fake backend that provides some observables. Junie created this model. I added the empty TMNT character. We're going to go into that a little bit later. I want to make sure that we're doing good on time. But let's take a look at the tests that we wrote for this, right? So this is like in, I would say most Angular projects where we've written tests and we have components, this is probably going to be the most common style of test that you're going to see, right? And we actually learned from Matthew on Twitter this week that, hey, this compile components may not be necessary. Are these Junie created tests? Some are Junie created, some Junie created tests that didn't work that we modified, and some are tests that we wrote ourselves to represent, um, typical tests, right? So like this test right here, I've seen this in almost every Angular project I've worked in, right? It should render or it should create, right? And we get the fixture, we get the component, and then we expect the component to be truthy. Um, I worked with, if you guys know Q, I worked with Q. I agree with Q now. In the beginning, I didn't so much agree with him, but I agree with him now. This is the most worthless test ever. Why is this worthless? Well, other things that we typically see is, we remove validation for components. Maybe we mock components. this doesn't really do anything. It's not really an integration test. It's not really a component test. It's not really a unit test. Um, this test isn't useful. So then we look here at, it should render the title. Um, what's wrong with this test? This test is very brittle. Um, this is another Junie created test. It's an automated test that shows, we should be doing this. Actually, I don't think this is Junie. I think Junie ran the generator, and the generator generated these two tests, right? Um, this test, the problem we have, right, is that we're relying on an H1, right? So what breaks this test? Well, what if I just go here and in my template, I had an H1 here and I broke your test, right? I've broken that test. And we can validate that by saving this. Um, come on. Let's go here and let's break out of this. And let's just run our test, right? So npx nx test, and we're going to do our testing structure workshop. And I found that I have to add verbose. Um, I think NX21 will solve this issue, but for right now, I've got to add verbose to be able to see how this test was broken. Well, not how it was broken, but if everything passes, um, then we can't see the test that passed. So I've been adding the verbose to see that. But we can see that right away, I've got a very brittle test, right? I broke your test. Um, and this is a contrived example, but it's a powerful example of ways in which we write code that can only be tested in a certain way. And by testing in that certain way, what is going on here? Let's see. For whatever reason, Zoom's not letting me swap. Um, but so, um, you know, after removing that H1, our tests pass again. Um, and this is this is where the philosophy comes in, right? And there's a lot of philosophy that goes on here, right? Um, a lot of the arguments against testing is that testing is expensive. If I make any changes, then those changes have to be tested, right? And I think a lot of that comes in because of the way we're structuring our code. We make it difficult to test our code. So I would contend that things like this are not unit tests and shouldn't be put in unit test files. Things like this should be put in component tests. They can be put in snapshot tests. They can be put in end-to-end tests where those tools have better things in place for you to make sure that things are less brittle and break less often. So that's my first piece of advice, is pick the right kind of tests for what you're testing. But we can do stuff that will make picking those tests easier. And we'll take a look at that here shortly. Um, so, um, this saying, hey, the app should have a title and things like that. Again, these are not good tests. They don't really provide benefit. So now we're getting into some stuff that we're going to run into some issues. And one of the first issues we're going to run into has to do with when we start testing characters, right? And you'll notice that I've got notes here. Fake async doesn't work um, with our tests. Um, and there's a reason for that. Fake async works if we add this set timeout. Um, and I will prefer to use ID test instead of classes. Classes change. Exactly, Teddy, right? And those are conventions that tools that are designed to test components or do integration testing have in place. Those aren't the kind of tools that you should be using in unit tests. Can anybody tell me why fake async fails, but set timeouts makes our tests work? And let's go take a look at the code that we're trying to test. We're trying to test getting all the characters. And so we're calling our service. Our service returns an observable. We're subscribing to that observable. We're then taking the array that we get from that observable and we're stuffing it into all characters, and all characters is an array. Um, does anybody have an idea why we're having to use set timeout? And um, this use case was specifically called out by members of the Angular team, and set timeout is the way to fix this. Um, the other way to fix it is with detect changes. So these both cause the expect to work. Anything else that we do doesn't allow the expect to work. Um, let's see how long we don't have much time left. I want to leave some time for questions at the end. It comes down to change detection, right? Um, the way Angular change detection works, the subscribe, when the observable emits, we get a change detection cycle. The subscribe happens after that. All characters is set after that. Um, and so with the way this code is written, we actually can introduce a bug where, maybe the characters don't update until you move the mouse or click a button or cause some sort of change detection event to happen, right? The top characters, maybe they, right? And we've experienced this in applications before. And it comes down to the fact that we're using these arrays, and these arrays, right, the way change detection works in Angular, these arrays, it's not recognizing, right, the change detection isn't firing. So how do we get something to fire on the next change detection cycle? We do a set timeout and we give it a 0 delay, and that moves it into the next task queue. And when that next task queue kicks off, set timeout completes. That causes change detection, and so the change detection happens, and then our expect succeeds, right? It's the same with fixture.detect changes, right? We're manually kicking off another change detection cycle, and that's allowing things to happen, right? And we run into this all the time in our unit tests. Or at least I have, right? I don't want to bring you guys down to my level when we're unit testing. But I often make these weird decisions like, oh, I just need to make the unit tests work, right? That's the wrong philosophy to have, and it shows that our code structure is wrong. Um, there are other things that are wrong with this class, right? So one of the things is, hey, maybe I want to check what happens if all characters changes. Well, because of the way I've written my code, I could come in here and I could just say, hey, app.allCharacters equals, and now I've got access and I can mutate the all characters and cause things to happen. But this does not test the code the way the user tests the code, or the way the user would interact with the code, right? The user is not going to drop to the console. They're not going to get they're not going to use Angular to grab a reference to this component, and they're not going to set all characters to something, right? That's not the way they work with the code. Um, so we have other issues with our code structure that's going to push us in a direction of writing tests that are not the way the test should be written. There are other things that are going on here, like the load characters. If we take a look, um, right, maybe we don't want to instantiate this, but maybe we want to test a refresh action, right? And we want to use load characters to do the refresh. Um, very, very common pattern is to just call app.load characters, right? Um, and this is perfectly fine, right? Because we've got a publicly available load characters, and that publicly available load characters is going to give us access um, to things that we shouldn't be interacting with because the user can't interact with them. And the problem with this is the same problem that we've got here, right? We can go into our code. Um, And this simulates not wiring up a button or something like that. But if I just comment out the load characters here, um, our unit tests are broken, right? Um, but we because of the way it's structured, because we've written kind of an iPhone style where everything's crammed together, and I don't mean to say iPhone, that's just the most common. I'm not trying to call out issues with the iPhone, but notice my tests pass even though my load characters is commented out, and that shouldn't happen, right? If we look here, um, it really shouldn't pass. Why is it passing, right? We haven't called the thing to load in the characters. What's going on? And now we're in a weird situation where our code is broken, but our tests don't catch it. And this happens all the time for me with buttons. And that's where, I'm calling out something like this, where we've got this button and we're setting the selected character to null, right? I forgot to wire up the button. Or maybe my skills aren't right. And so I've got logic in the template that's handling the skills. So how do we fix this, right? How do we write our code in such a way that these problems don't exist? And there are a lot of other issues that can happen. But let's focus on what we can do to fix this issue. And right away, one of the things we can do is we can just go in and anything that's used in the anything that's used in the template, we can just make it protected, right? And this was something that was added, I think it was in Angular 15. Um, but by making these protected, we can no longer write code like we were writing before, where we would grab the app and try to change all characters. That's no longer possible, right? We can't change ng on init because it has to have a specific implementation, but we can do something about this ng on init, and we'll take a look at that. The next thing we can do is anything that is not used in the template, um, we can make it private. And I recommend using like true private variables and true private functions. And now we've encapsulated our class. And this takes away some of the common testing pitfalls that we'll fall into, right? I can no longer access all characters. I can no longer access load characters. I can no longer access show details. But we haven't really moved. We haven't really moved from using our phone as a flashlight to an actual flashlight, right? We don't have components that are composable. We're still, everything's all crammed together. The state is still in our code. Our code is still difficult to test. We aren't encouraged to write, well, we have made one big step with what we've done here. The big step we've made here is we've now encouraged people who want to test this component to use component tests, right? Whether it's Angular testing library or whether it's Cypress testing components or whether it's Playwright component tests, Cypress component tests, whether it's Cypress or Playwright end-to-end tests, right? Whether it's Jest snapshot testing. This component is no longer unit testable. And that is one step forward. So by thinking about encapsulation in our components, we can take something that, you know, people would test improperly, right? In a way that a user's not going to interact with it. We can encourage anybody who wants to test our class or our component now has to interact with it in the same way that our user would interact with it. So, when they select a character, they have to actually click that button and then test the HTML output, which is naturally going to push them towards, Cypress or Playwright or something like that. Angular testing library, Spectator. There's a whole bunch of tools out there that are much better suited for that than unit testing our components. And even the material, what is it called? I'm drawing a blank right now. Um, the material test harness is also great for doing component tests, right? All of those are better suited for component testing, but we're still smashed together. So what's the next piece? And so last night on stream, we built the testable code. And within the testable code, we went and we created a store. And it's a signal store. Yeah, a test host also, Caesar. Very, very, that works too, right? We want to be testing our code in a way that the user is going to interact with it. We don't want to be calling public methods on our code. And that's going to encourage us to write better tests for our code that better represent how that code will be consumed, right? Um, so I want to first give a big shout out to Michael Small. He's here. Michael created this gist. If you grab this off of the repo, I've got links to this, but he's got a very nice way to set up a component store, right? Or not a component store, a signal store. So what we've done is we've taken all of our state and we moved it into a signal store. There were a couple of things that we did. The original code written by Junie allowed our selected character to be null. We no longer want that to be null, so we need an empty character. If we add an empty character, then we're going to need a way to know if a character is selected. So we added a computed to make sure that a character is selected. This is important because this kind of stuff is very testable. It's logic that we can isolate and test, but it's also computed based on the current state. And that's an important part of our code, right? We should compute as much state as we can, right? Derive as much state as we can, but keep the state that we can't derive in memory. There's some other things that we did. We handle our observables much better. We're using Rx methods. This will handle our subscribes, our unsubscribes, but it also will handle the change detection better. But there's one more big thing that we gain out of this. Our store is entirely testable. We can isolate all parts of the store, right? Again, this is this is just me being silly, right? Again, right? It should create the store. This test really, I would argue this has more value than the component test, but I'm not sure how much value it has, right? It should load all characters. Well, because we're using a store, we can control the observables that we're providing through the service. which means that we can omit the observables when we want to, which means we get better control over observables. And notice in here, I'm not using any async. I'm not using fake async. I'm not using, detect changes. This just behaves how I would expect it to behave. I can get everything how I expect it to be, right? The same thing with the top characters. Um, and the same thing with selecting a character. We can select a character and verify that that character was selected. We can also deselect the character. Um, yeah, anything exactly, anything that can abstract async out of our tests, right? We want our tests to be as simple as possible. The other important thing about tests is when I read the tests, I should see what's important to that piece of code, right? The other nice thing about this store is now I've got a store that we can put anywhere. Um, so let me look. Yeah, we've got time. I definitely want to leave some time for questions, but let's look at what this code looks like. And we aren't going to have time. I wanted to do like a bonus action of abstracting um, out components for testability too, because if we want to think about things. Oh, I went the wrong place. If we want to think about things, right, we can think about our stores kind of like the batteries. They provide the power to our application, right? The the template and the components that make up the template, we can think about them kind of like the bulbs, right? They're the pieces that we see. They allow us to see what the batteries are providing. And then, the glue that holds it all together, the framework and stuff is the flashlight body, right? But abstracting out templates so that things are composable is another big piece. And it's something that we talk about definitely on stream. I don't know that we're going to have time to do it today. But let's dig in and let's just see what happens when we convert this over, right? So the first thing we're going to do is we're just going to take all of this out. We don't need all of this state. And because we don't need the state, we also don't need the service that provides state in our component anymore. So now what we can do instead is we can inject our character store. Um, and we will just inject our app store. And let's fix this to be app store, right? And actually, let's make it protected and read only because we want it to be available in the template. And that's the important thing here, right? Is that come on, you can do it. I know you can do it. There we go. So, and let me close this so that we can see all the code. So now we've got the app store. The app store is our state. We've now taken the batteries out of the iPhone body and we're now moving them into that we're moving them out so that they can be placed into our code where we need them to be, right? We've got problems though, right? All over the place. we've got we've got to go in and we've got to fix things up, right? The other benefit of using a signal store is now we're getting signals, and signals are amazing in templates, right? Signals are really, really good to use as close to the user as possible. So by using a signal store, we're gaining some abilities here, right? Um, So we gained testability, but we also gained some predictability in our template. Right here, we have to change this. This no longer makes sense because if we just did an if on the selected character, then it would always be truthy because we have an empty character. So we added the computed, and the one we added was. I believe we called it character selected, but I just want to make sure. Yeah, character selected. So, so there we go. So now our if statement works. And then the last thing we can do is we can just say, hey, let's define a selected character. Um, and there we go. And that cleans up all of our code here. And the last thing we need to do is just handle this where we had logic, like business logic in our code before. Now we can just say, hey, app store dot deselect character. Boom. Right? So we've removed all of that, but even more than that, because we're using hooks in our store, when our store is created, we're going to get these on init hooks. So we're going to get these values run. We no longer need this code right here. And that means we no longer need this code right here. Um, so we've now cleaned up a whole bunch of our code. And there's we've removed a lot of the temptation to want to unit test this because our logic no longer exists in our code. The last thing we need to do is just handle the show details. And we can just handle that through our app store dot select character, right? And there's I mean, when you test this, you could inject a variant of the App Store for your component and just make sure that select character is called, and that's perfectly fine. But the only way for you to test that is for you to actually click the button where, show details is called. And so what we've done is we've taken a component that was written by Junie. And I don't want to bag on Junie here. This isn't me trying to dunk on AI because AI sucks and real coders are real coders and blah blah. That's not it. Junie is trained on the code that it has seen. So Junie has seen that code over and over again. That's the thing about LLMs. LLMs don't come up with things on their own. They come up with things that they've seen before, right? That's the way the embeddings work. The embeddings point the LLM to the code that it should generate. So Junie saw that code enough that it thought that that was the best code to write. Um, we've taken that code that you will see anywhere, and we've applied some simple principles, right? The first principle that we're applying here is we're we're encapsulating our code, right? And this applies to functional code as much as it applies um, to class-based code, right? Like Angular is class-based. It's moving away from that more and more, and like the work that like Brandon and Chow and the analog team are doing is moving Angular more and more towards composable code. And I think we'll see more and more composable code in the future from Angular. Um, but we can encapsulate composable code too. For example, here within our hooks, we inject the service here. The service isn't reachable anywhere outside of this hook, and it's only used in this hook. And once it's done, it's gone. We don't have to worry about it anymore. So right, we're encapsulating our service within our code here. It's not, I can't grab that service. So for me to interact with that service, I have to provide a mock, which is why we're using DI, right? So by encapsulating this, now we force the user, or we force the tester to test this in a way that the user will interact with it. That's going to make our tests more likely to catch bugs before they make it out to the end user, right? Like most of the bugs that make it to the end user that I encounter are either from improperly tested code, right? Like tests that don't really matter, or from code that doesn't catch issues in templates. And the majority of the bugs that I've produced in the past happen to be where the templates don't line up. Um, so this is the philosophy that when I want to call myself a code philosopher, I want you to think about your philosophies, right? There are other things that we could clean up with this code. But I don't, this isn't about dunking on Junie. This isn't about dunking on AI. This is about taking code that you're going to find at your job today and thinking about it critically, right? And that, like, one of the big pieces that we've been talking about on stream is, how do we survive AI? As developers, as engineers. And a big piece of surviving AI is thinking critically, right? So think critically about your code. Think, how can my code make the next person that comes along interact with it in the way that I want them to? And there's tried and true methods that we've all learned, as we've become developers. The ideas of encapsulation, the ideas of, limiting API surfaces, the ideas of, composability, taking pieces and making those pieces small and focused on what they need to do, testing the heck out of those pieces, and then composing those pieces. But then we only have to test the places where we compose them, right? Where we integrate the pieces, right? So integration pieces, tests become a bigger part. And that's kind of where I want to leave things today, because I want to give some time for questions. Um,
There
so
was
yeah,
one that kind of got drowned out there, and I don't think you addressed it. I don't remember you saying anything, but he just said, "What about using something like test host to test our components?"
test host. I look at test host similar to the um, Angular material component harness. And a test host is, and correct me if I'm wrong, Cesar, but when I think about a test host, and if I'm misunderstanding you, please correct me. I'm thinking about something that can grab the pieces out of HTML, right? So my test host will give me access to buttons. My test host will give me access to inputs, and my test host allows me um, to click a button or to add inputs, put stuff into inputs, or to do key events or things like that. So I look at the test host very similar to, the way that they encourage you to write playwright tests, or the way that Angular Material Test Harness works. Um, I those are component tests, and they're the right way to be testing your templates. So totally agree with that. But definitely correct me if I misunderstood what you mean by test host, Cesar.
No, Jason, that's right. I try to use the test host to test the more of the template I can.
Yeah, and that's the right way to do it, right? Because that is encouraging you to test the template the way the user is going to test the template. Um, and we can encourage that kind of testing through encapsulation, through compartmentalization, through integration, through you know, composability, things like that. All of these, all of these important terms, right, that have been around forever, but you know, thinking about our code critically. Yeah.
Another one that just popped in. You said about state slices. So is there a problem if you have your state like data state null, or you meant something
Yeah.
different?
So Oleg, if you're the Oleg that I know, I'm disappointed that we didn't get a flashlight, but I'm not sure if you were there last night. Um, but that is a great question, and um, I hate null. I hate undefined. Um, I hate undefined more than I hate null. Um, like null exists because of SQL, but the person who came up with null calls it their $1 billion mistake. Um, don't use null or undefined, and it's easy for me to be perched up here on my in my ivory tower saying, "Thou shalt not use null or undefined." what happens when you use null or undefined, right? You it basically becomes there's a Terry Pratchett's Discworld talks about the Discworld's carried on the back of a turtle. And somebody asks, well, what's carrying that turtle? Well, it's another turtle. And what's carrying that turtle? It's another turtle. It's turtles all the way down, right? This is the same thing that happens when you introduce null or undefined into your code. Um, as soon as you add null or undefined, it's null or undefined all the way down, right? And you have to be checking over and over and over for that null or undefined. Um, we don't have time to go into it, but if you go to my YouTube channel, we've got streams about this over and over again. What do I recommend instead? Um, I recommend optional or maybe that comes to us from we get that um, from functional programming. An optional or maybe is a monad, um, and basically by making something optional, you can have something happen when it has a value, or you can have something happen when it doesn't have a value, right? It represents that this thing can or can't have a value, but to interact with it, it has to have a value. Um, so it's what you're asking is a much deeper question. But you're with your slices of state, I recommend not using undefined. And we kind of cheated here with the empty object. The empty object is not necessarily the best way to handle it because it leads to things like this. If we'd used an optional or a maybe monad here, character selected, we would just have we could just interact with it, and when we interact with it, if it doesn't have anything, nothing would happen, and if it has something, then what we expect to happen would happen. So hopefully that answers your question, but there's a lot of hand waving there because I don't want to go too deep into you know something on the side. I think, and this is what really inspired me to prepare this workshop for today, is as developers, if the only way we differentiate ourselves is by the code, AI has already beaten us, right? And Junie proved that to me hands down, right? 3 sentences and it produced the application faster than I could do it. It probably would have taken me, maybe an hour to produce what Junie produced in 30 seconds. Um, that's, if all we do is write code, that's scary. Um, so, how do we differentiate ourselves? Well, we can differentiate ourselves by making the code that we produce the cheapest for the company to, for the company or organization that we're a part of to maintain, right? And when I talk about maintain, it's not only writing the code, but it's also finding people who can understand the code, and it's also, the long-term maintainability of the code, right? Like if I want to make a change, it becomes much more difficult if everything is the iPhone flashlight, right? Where if we treat our code like a flashlight and we treat it composable, it's much cheaper for the company to get that initial investment, but it's also much cheaper for the company to replace batteries, right? We can replace batteries really, really cheap. It's $700 to replace the iPhone. What's the $700 replacement? Well, that's the rewrite. And how many times have you guys been at a company where, oh, the old system sucks, we need to rewrite it? Um, so that's where our benefit is going to come in. At least that's me as the code philosopher coming in.